All right, we're back. This is the video for 7.5, and this should be pretty short. Rather than starting with the blank sheets and just filling them all out as we go, you can find the blank version of 7.5, but you can also find the totally filled in version of 7.5 on Blackboard as well. And so that's what I'm just going to use here, and I'm just going to make comments on things and rather than write it all out. All right, so first off, vectors, when we draw them in the xy plane, look like we had before. What we didn't talk about before was the point at the end of the vector. If you imagine the vector coming out of the origin, the end of the vector is at some pair of coordinates, x and y, which we're calling a and b here. And you can describe a vector just by talking about where that endpoint is, assuming it starts at the origin. And to distinguish between talking about a point, which has the coordinates in a pair of parentheses, we're going to talk about, or the way we label it is with these angle brackets instead around the same set of numbers. All right, and you'll see those throughout. And the magnitude is still Pythagorean theorem, gives you that guy. Now, when you have vectors written just in terms of the coordinates where they end, adding and scalar multiplication, these things are very straightforward. You just add or multiply the corresponding pieces. So when if v is this vector and u is this one, to add them together, you just add the first two coordinates and you add the second two coordinates, or you subtract if it's subtraction. So you get this kind of formula right here. And if you take a real number r and you multiply it by, or multiply the vector by that to scale it, which means stretch it or shrink it, you just multiply each of the pieces, almost like you're distributing r onto the coordinates of the vector. All right, so these then are just a bunch of practice in adding coordinate-wise. So if here's v and here's u, if you do v plus u, well, 1 plus 3 gives you the 4, and 7 plus -5 gives you the 2. Subtraction goes similarly. If you do 3 times v, so you just do 3 times 1, which is where the 3 comes from. 3 times 7 is where the 21 comes from. Here's a -6 times u, and you just multiply each coordinate of the vector by -6. So a little more complicated. What if you took 5 u's and you subtracted 2 v's? Well, first you'd have to multiply by 5 to get 5u, multiply -2 times v, and then actually do the subtraction, and you get the result here at the end. All right. Some special vectors are called unit vectors, and they are any vector that has a magnitude of exactly 1. So there's lots and lots of unit vectors that point in any direction, but 2 of them are particularly special, and that's I and j. So I points in the positive x direction, and j points in the positive y direction. So in terms of coordinates, that's 1, 0 for I and 0, 1 for j. They're vectors, so when we write them, they get the vector hat. Now, typed, they'll come out in boldface, and we put the vector hat on them if we write them, but we don't go I and then put the dot on the I and then put a hat on top of that. We just make the I and use the hat as the dot as well. So the thing is, I and j can become basic building blocks for vectors. So every single vector can just be written in terms of a combination of I and j. So if v was a comma b like this, then taking it apart, well, first off, okay, here are the coordinates that go with v. You could separate them like this into basically a horizontal vector and a vertical vector, right? That's the vx and the vy that we talked about before. Well, each of those is just a real number. You can sort of factor out that real number so that a comma 0 is just the same as the real number a times 1 comma 0, and likewise for b. But 1 comma 0 is I, and 0 comma 1 is j. So this a comma b, the way we wrote those coordinates for v, you could actually just write that vector as a times I plus b times j. All right, here's basically your horizontal part and your vertical part. So, like we did in the last section, if all you know is how long the vector is and what direction it points in, we saw that, well, we get the sizes of the horizontal and vertical pieces by doing magnitude times cosine theta and magnitude times sine theta. So that would be our A and our B. So in other words, your vector, if you just know magnitude and direction, you could write it with its components and in terms of I and j, like so. So the next example is just do some basic arithmetic with vectors written in terms of I and j. So if v is 5i minus 12j, which is the same as saying v is 5 comma negative 12, and u would be the vector 8 comma 15. Well, to do the addition, you really just combine like terms as if these were just good old unknown variables. 5 i's plus 8 i's makes a total of 13 i's, like so. Minus 12j, add 15 j's, you've got 3 positive j's. All right, subtract, just you do basic algebra here. Distribute a 3 when you multiply by 3. Again, magnitudes are just Pythagorean theorem. So there you go. Slightly fancier one here, like this. Then one good messy example here. So we have two vectors and we know how long they are and what direction they point. Right, and that's it. So we're going to change them both into horizontal and vertical pieces so that we can then add them together easily, and then we'll figure out how long and what direction the result points in. So first off, these computations for v, right? Horizontal component, vertical component, which means v looks like this in terms of an I and a j. Same thing for u, horizontal, vertical, la, 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 la. There it is in terms of I and j. And once they're written like that, you can add them together quite nicely. Oh, and I totally skipped the direction stuff up here. So let's do that up here. What direction do these guys point in? Well, v, 5i minus 12j, or in other words, 5 comma negative 12, if you're even to think of that as a picture, well, that'd be 5 here and negative 12 down here, so this vector points, oh, come on, kind of here-ish. So we would expect it to have an angle somewhere in the fourth quadrant. Now, if you use the tangent result that we had from the previous section, you'd take vertical length over horizontal length, or vertical and horizontal components. That has to be the tangent of the angle. So we do an inverse tangent, and your calculator will give you a negative result. And if we want the actual fourth quadrant result that points in the same direction, that's what the 292.6 is. We just add 360 to make it spin around and get a coterminal angle. We do the same thing for u, we get a positive number here, we get a quadrant 1 angle. So down here, well, once we know what v plus u is, Pythagorean theorem will get us the length of it, the magnitude, same tangent process would give us the direction that it points in. All right, and I'm kind of speeding through things here rather than writing it all up, but you can look through the work and check it and see where it came from, and then ultimately to see how things went. The third page, which I'm not going to scroll all the way down and look at, this would be stuff that I'd have you do in class, just basic arithmetic and whatnot with vectors. So do that, and then you can open up this actual filled notes for section 7.5 and you can see how it went. All right, then that's going to be it for 7.5.